Well, good morning, welcome. What we're going to be talking about this morning is JDK 9, and specifically around modularity, which is finally coming to Java. I say finally because I'm sure you remember that JDK 7 was supposed to introduce modularity, Project Jigsaw, and then they decided to delay it by a little bit, so they decided to get it into JDK 8, and then JDK 8 came and no Jigsaw. So then it was JDK 9. So hopefully, JDK 9. I'm fairly confident that it will be available in JDK 9 because most of the code changes have actually gone into the build environment now. So if you look at OpenJDK, most of Jigsaw is in there now. Right, so what are we going to talk about? First thing is to talk a little bit about some of the structural changes that are being made in terms of the APIs around Java. And this is quite important because it will have some effects on compatibility. So we need to understand what the changes are that are going to be made here. Now, if you look at the way that the rt.jar file that we have in Java is made up, you'll find that there are a number of public classes, ones that you are entitled to use, ones that people who design these things want you to use. And those can be broken up into two parts. There's the java.star packages and the javax.star packages. Those are both ones which are defined through the JCP, through the JSRs for Java SE. So they're part of the standard, which is Java Standard Edition. Then there's a few other public APIs which you're quite entitled to use, you're encouraged to use, which fall into packages like com.sun.star and jdk.star. And these things tend to be around areas which are not specifically part of the core Java platform in terms of the language, but are things that make up the JDK. Examples of that are nashorn. So if you want to interact with the JavaScript engine, which is part of the JDK, you can do that through an API. If you want to interact with the compiler, if you want to write code which compiles code in turn, you can do that through a public API. But then there are a whole set of APIs which are in rt.jar, but they are there to make the public APIs work. So they're really private APIs. And these fall into the sun.star package. Most famous of these is the sun.misc.unsafe class. Now, I personally think this is a great name for a class, unsafe. There's a clue in the name. Anyway, now, in terms of JDK 9, there are going to be some incompatible changes. Sun and Oracle have been very keen to maintain backwards compatibility. So the idea is that you can take code that you've written in earlier versions of the language, you can compile it, it will run on later versions of the language. The idea is also you can take binary class files and run those unchanged on later versions of the JVM. That has worked pretty well. In terms of binary compatibility, you really have to go way back to sort of 1.02 versus 1.1 to see any break in terms of compatibility. There was some changes in the class file format that did change things at that point. Source code compatibility, there've been a couple of things, JDK 5 and JDK 1.4.2 introduced a couple of new keywords, so there was some source code incompatibilities there. But on the whole, very compatible. A couple of things that will change in JDK 9. So one is about encapsulation of these internal APIs, and we'll talk more about that in the next couple of slides. Deprecated APIs. This was introduced back in JDK 1.1. Things were annotated or marked with the deprecated tag, and so the idea was that you knew that things like thread.stop was not supposed to be used, and it would be removed at some point in the future. Of all the classes and all the methods that have been deprecated since 1.1, not one single one has actually been removed until now. There will be a total of 6 methods that will be removed from JDK 9. So this is a fairly small start, but it's very significant, and I'll explain why those 6 APIs have been chosen above all others a little bit later on. Structure of the JRE and the JDK, that's also going to change a little bit. So if you are depending on where files go for some of your application code, you might need to change things to reflect the changes that are in the JDK 9. There is a new version string format. I won't go into details of that, but essentially it's just the way that the versioning works is going to be slightly different. Again, if you rely on the format of the version string to test various things, you might need to make some changes to your code. There was an interesting thing that I saw just a couple of days ago, is that anybody here use Cassandra? Nobody. Okay, well that's good, you see, because Cassandra, oh, one person. Okay, be aware that Cassandra is now broken. Because Cassandra, if you use the JDK with it, if you use the latest update of JDK 8, which is version 101, they've gone to 3 digits. Guess what Cassandra does in terms of checking the version number? Yes, it doesn't take account of 3 digits. So there will be a change for that. The other thing is you will no longer be able to use a single underscore as a variable name. Hands up anybody who's used a single underscore as a variable name. Very good. There is actually one situation where it actually makes a lot of sense, but I won't go into that right now. Right. Now, one of the proposals originally for the APIs was to simply say, right, all of these private APIs, all of these internal APIs would simply be encapsulated in JDK 9. That meant that you would no longer be able to use them, and because you've been told for many, many years that you shouldn't be using them, well, it's your problem. And that didn't go down so well. So the people at Oracle, the people on the JDK team said, okay, well, we understand that some people have used things like sun.misc.unsafe, and so they need to be able to continue using that or some alternative. What they've done is they've divided the internal APIs up into 2 groups. There's non-critical and critical. Non-critical is basically ones which have essentially no use outside of the JDK. They're so specific to the JDK itself that they don't make any sense to worry about. Then there's some internal APIs which have alternatives that you can use elsewhere. So it's fair enough to say, right, we are going to encapsulate those, you will have to change your code. Good example of that is base64 UU encode, UU decode. Those were internal APIs. Now there's a public API in JDK 8, so if you're using the internal API, you can switch to using the public API. It's not a problem. And then there's critical APIs. And the critical APIs are things where you've got functionality that's just too difficult to replicate or just downright impossible to replicate outside of the JDK. Things like sun.misc.unsafe, there's some system signal handling stuff, there's some reflection stuff, and also some finalization things that kind of fall under that. There's about 6 classes which are considered critical. To sort of explain exactly what's happening, there is this thing called a JEP, JDK Enhancement Proposal number 260. And what that says is that they are going to encapsulate all non-critical JDK internal APIs. So those ones you as developers don't really need to worry about. They will encapsulate all critical JDK internal APIs for which there is a supported replacement. So again, it's there's a few that will be still there. You will need a command line option to enable that. So by default, they won't be visible. You can turn them on if you really need them. So if you do need misc.unsafe, then you can still use it. The ones that are still made available are being made available only for JDK 9. The idea is that in JDK 10, they are being deprecated, and either an alternative will be provided or they will be removed completely. But this is a gradual process, and as developers, you might have to make a few changes, but it's the idea that there is a migration path available to you. Now, if you want to know whether you're using any of these APIs, there is a nice little tool called JDEPS. It was first introduced in JDK 8. It's been improved and enhanced for JDK 9. And that will tell you what APIs your application is using. And you can run it on your jar file, find out what things you're using. A lot of the time you might think to yourself, well, I've written the code, I know I'm not using any internal APIs, so I'm all good. But be careful, because if you're using anybody else's jar file, they might have written code which does use internal APIs. So it's a very good idea to run JDEPs on all the jar files that you're using in your application. That way you can test and make sure that there are no dependencies that you need to change. Right, so let's talk about the module system and Project Jigsaw. So we talked about the APIs and what they are in terms of rt.jar. First thing is fundamentals of a module. Now, a module is just a way of grouping together packages. And if you think about it, we already have ways of grouping together things in Java. So a class is a way of grouping together data and methods. Classes can then be grouped into packages so that you have relevant classes grouped together. A module is the next level up. So we're saying that you can group together relevant packages and put them into a module. In terms of what can go into a package, you really don't have any limitations. You can have, obviously, packages, you can have classes that you want to use in your application code. But if you're using things like J and I, then you can also put runtime libraries, native libraries, into the module so that they're available as part of that, and you can distribute it. You don't have to worry about having to have separate files for that. You can put resources into a module so that if you're doing translations for multiple languages in your application, you can put all the resource files in your module. Similarly, if you want property files and configuration data, that can be placed into the module as well. What I've done here is I've created a very simple module, so I've called it com.azul.zoop, and within that I've got two packages, alpha and beta. They have various classes, name, position, animal, zoo. Great. How do we create a module? Well, in its simplest form, what we need to do is we need to create a module info.java file. And that's what needs to be provided along with the classes and the packages that we want to make part of this module. In its simplest form, all you need to do is specify module, the name of the module, and then an empty set of braces. Now, immediately people look at this, they go, ooh, hang on, so that's module. Now, does that mean module is now going to be a reserved word in Java? So I can't use module as a variable name anymore. Well, the answer is no, it's not a reserved word. So it's not changing anything in that sense. Because even though it's a module info.java file, it's not really a Java file. So why would you call it Java if it's not really Java? Well, the reason is that in order to make life as simple as possible for you as developers, what the designers of Jigsaw wanted to do was to allow you to use the existing tools and runtime technologies. So we call it modulinfo.java, even though it's not really a Java file. So you don't need to worry about being parsed in the same way and affecting other Java code. When it gets compiled into a modulinfo.class file, which is created by the compiler and can then be used by the runtime to understand what the module is. But it's sort of separate from the rest of the application code. It doesn't really interact with the application code in terms of functionality. It's just there to allow the runtime to understand about the module. So simplest form, just the name of the module, and that's what it is. Modules can have dependencies. Same as you have dependencies in other parts of a system. What you need here is a way of specifying that in the case of our module called Zoop, there are packages and classes that Zoop depends on which are outside of the Zoop module. So we need to say that this module depends on another module. So we create a module called Zeta that has some packages and classes that we need in it. So to tell the system, the runtime system, the compiler, that we have a dependency, in our modulinfo.java file, we place a requirement within the definition. So within the braces, we can now say requires com.azul.zeta. And that way the compiler knows that there's a requirement on module Zeta, and the runtime, JVM, can also determine that there's a requirement on Zeta. We can specify multiple dependencies, and these dependencies can extend to modules within the JDK itself. Now, I'll come back to the module breakup of the JDK a bit later on, but for now, you can see that we have a module called java.sql. So our app, so we'll switch to an app now, will have a dependency on the Zoop module, and it will also have a dependency on the java.sql module. So we specify that in our module.info.java file in exactly the same way. What this allows us to do is to build up a dependency graph. And so the compiler will look at this and it will go, okay, so we've got app, that depends on Zoop. We know that Zoop has a dependency on Zeta, and we know that we have a dependency on java.sql. Now, all of those modules have a dependency on java.base. But this is an implicit dependency. We don't actually have to specify it in the module.info.java file. We can if we want, but we don't have to, because it's implicit. All modules depend on base. So it's a bit like all classes ultimately inherit from object. In this case, all modules depend on base. So we have a dependency graph. And then, because we know that java.sql might depend on some other things, we'll find that, okay, that depends on java.xml, depends on java.logging. Both of those also depend implicitly on base. So we now have a nice dependency graph that the compiler can use to resolve references, the JVM can use to resolve references. What we also need to understand is the difference between readability and dependency. So here we've got our app, which depends on java.sql, and we know that java.sql depends on java.logging. And if we look at the code that we might create using SQL, we might have a situation like this. We create an SQL driver from somewhere, and then what we can do is from that driver, we can get a reference to a logger, so that we want to be able to log messages. And then we log a message. Perfectly valid code, that's what we want to be able to do. And we know that SQL has a dependency on logging, so that's all good. The problem is that app, even though it has a dependency on SQL, doesn't have an explicit dependency on logging. So how do we resolve this? Because if we use modules to restrict access, which is what we want to do, then the compiler is going to go, well, hang on, we don't know where logging comes from, there's no dependency. Obviously, we could go down the route of saying, well, okay, I know that I'm using SQL, so I will put an explicit dependency in my app module.info.java file to say it also depends on logging, and that would resolve the problem. But that's not really a very clean way of doing it. So what we do is we allow within the module.info.java file to specify implied readability. So when we specify requires on a particular module, we can also say requires public. We can add the public modifier. And what that will do is it will say that all the publicly accessible packages and classes of the logging module will be made available automatically to anything that depends on java.sql. So it's really just re-exporting the publicly accessible members of logging to anything that depends on SQL. Which then allows us to build a little bit more detail into our graph where we can have the implied readability. So now that we've got java.sql, we can add in java.xml, java.logging, and have this implied readability on both of those modules because they're specifying that they require publicly in java.sql. So we get this implied readability, everything can be resolved without us having to explicitly put the necessary statements in the code. Which then allows us to look at package visibility, because not only can we specify dependencies on other modules, we can, within our module, say that we only want to export certain things, because we might have various classes and packages that are used within that module to build the public interfaces, which we don't want exported. So this is like the sun.mist.unsafe. We don't want to export that. So in our module.info.java file, we can specify a requirement from Zoop onto Zeta, but we can also say that this is going to export alpha and it's going to export beta. But there's another class in there that's called theta, which we don't want, or another package called theta that we don't want to export. So when a class or module uses the Zoop module, it will be able to access public classes from alpha, public classes from beta, but it won't be able to access any of the classes, any of the methods in the theta package. So it encapsulates things so that they're not publicly available. Aha, good question, yes. So if you do not specify exports, any exports in your modulinfo.java file, then everything will be exported. So that then gives us the ability to define accessibility. And accessibility is essentially saying that in order for a package within your module to be visible to another module, firstly, that module has to define a requirement on the module, but also your module has to export that package externally. So it's a sort of two-way thing that you need to specify. Then let's look at JDK 8. Now this is the dependencies. Don't worry about trying to read any of this. This is merely a sort of eye test chart to give you a sort of idea of what's going on. This is the packages, the modules which have been defined in JDK 8. And this is not a simple thing to do because you've got literally over 4,000 classes that need to be broken up into manageable modules, grouped together classes that make sense. And if you sort of drill down into a little bit of detail on this, what you'll find is that there's Java WS, which is web services, and that has a dependency on the beans module. So you think, okay, yeah, Java WS has dependency on beans, yeah, that kind of makes sense. I can see there might be some reason for that. But then you also look at another bit of this, and you'll find that there is a link between beans and desktop. So you think, okay, yeah, desktop has a dependency on beans, okay, I can see that. But there's also a dependency going the other way. So beans depends on desktop. And you think, well, hang on, how can beans depend on desktop? And the answer is that when the beans package was actually created, way back when, the person who developed it thought, well, we'll create a bean descriptor. So bean descriptor will have a name, it'll have like some information about the bean and so on. But wouldn't it be nice if we could also have an image associated with that bean descriptor so people could put it up on the screen? Don't know why, but apparently they did. So in order to render that image, you need a dependency on desktop, which has AWT, which enables you to process an image. So this is the kind of thing that makes things very complicated, because now you have a dependency between the web services, bean, and desktop, which means web services depends on desktop. So trying to break this up into manageable chunks becomes very, very difficult. They have succeeded. So this is the simplified diagram. So what we've got here now is we've got java.se, which is a sort of meta module. It doesn't contain any packages itself, but refers to other modules and groups those together. I won't go into all the details of this, but essentially you've got various different things. You've got the compact profiles from JDK 8. You've got all sorts of things like Java management. There's Java desktop and so on, Java.xml. There's also another meta module, which is java.se.ee, which is to be a little bit confusing. And this is the EE components of SE that are sort of, or the things that are relevant to EE, which are contained in Java SE. So these are things like java.transaction, there's java.sql, java.corba, just in case anybody's still using it, and stuff like that. Right, so moving on. A little bit about developing code with modules. First thing is, how do you create a module? And the simple answer is you create a jar file. So you create a jar file which includes the modulinfo.class file. That's the important bit that differentiates a module from just any other jar file. So you add the modulinfo.class file into your jar file, and that becomes a module. There's also things called JMods, but that's only being used at the moment in terms of the JDK modules, not for application code. There probably will be some changes to that a little bit later on. There's a new flag on the jar command, so now you can do jar -p, and that will print out information about your module. So it'll give you the name of the module, give you the required modules, and will give you potentially a main class. So you can specify a main class in your module definition so that it makes it easier to run your application. Linking. Linking is the idea of taking modules and bundling them together with the runtime. So you take the JVM, you take modules that you have built, modules that are required from the JDK, and create a runtime environment that only has the modules you need to run your application. How you link an application is using JLink. And you can specify a module path. You can specify, in this case, the app that we saw earlier. And what that will allow you to do is to take the module info Java file from that, compiles it, and says, OK, you need base, you need logging, you need SQL, you need XML, you need app, you need Zoop, you need Zeta. So all of the modules are bundled together. Only the modules you need are actually placed into the runtime. Now, you may get very excited at this point because you will notice that there's this at 9.0, at 1.0, and you may think to yourself, oh, look, we've got versioning. Finally, in our modules, we've got versioning. Do not get excited. This version numbering is for information purposes only. It has no bearing on what's actually used by the runtime system or by the compiler. And I actually put a quote from the document that is the state of the module system. It says, it is not a goal of the module system to solve the version selection problem, which is a real shame in my opinion, because isn't that part of what you really need? Okay, application migration. Just a couple of words about this, because obviously, how do you take an application you've written for JDK 8 and run it on JDK 9? Now, this is what an application typically looks like. You've got your JDK, monolithic JDK at the bottom. You have your jar files that you've written at the top, and then you've got the jar files that you pull in for different frameworks, different libraries in the middle. And what you're going to look like in terms of JDK 9 is very similar, because of course you've got all your jar files still, but now you've got modules in terms of the platform. So Java itself has modules. So how do you get jar files to work with the module system? Now, I've told you that you can make a module by adding a modulinfo.class file to your jar file, but it's a lot of work to have to take your jar files, unpack them all, add a modulinfo.class file, repackage them. So to allow compatibility, there is what's called the unnamed module. And the unnamed module is essentially the class path. Any jar files that are on the class path become part of one unnamed module. They will have dependency on all the modules in the JDK. They will have dependency on each other. So you can take an application, make no changes at all, and it will run on top of JDK 9. So you don't have to worry about modularizing anything until you actually want to. The other thing you can do is you can deal with what are called automatic modules. So at the moment, if you specify a jar file on the class path, it goes into the unnamed module. There's another path, which is the module path, so where you can specify where modules come from. If you take a jar file that hasn't been modified and you put it on the module path, then that will become an automatic module. If there's no modulinfo.class file in there, it will be treated as if it was a module, where the name of the module will be derived from the name of the jar file. All of the packages in there will be exported and will be made available publicly, and it will depend on all the other modules in the module path. So it allows you to kind of migrate your modules or your jar files from the class path to the module path and do that in sort of an easy way. So just to summarize, more information, modularization is a big change for Java. There are some things that, as developers, you will need to know about, that you might need to make changes to your code, or you might need to make some changes to how your code is organized in order to have those work correctly. There are a few potential disruptive changes, especially around encapsulation of the APIs and so on, making sure that if you have used private APIs in the JDK, that you have whatever changes are necessary. Modular code take a little bit of learning. There's a migration path to make it reasonably simple to get from one place to another, so it shouldn't be too difficult to migrate your code. Place to go for more information, java.net, openjdk.java.net is obviously where the OpenJDK project is hosted. A lot of information in various JEPs, JDK enhancement proposals, about various aspects of this. There's also Jigsaw as a specific project there, and also jcp.org. So the Java SE9 JSR, which is 379, the expert group for that has just been formed. I'm actually on the expert group. representing Azul, so that's going to be fun. Although it's going to be kind of interesting because most of the work's already been done, so it's sort of really retrospective standardization, but we'll see how we get on with that. And I don't know, I've got probably like maybe 5 seconds for a question. Anybody call? Oh.
What about class loaders?
Aha. Yes, so class loading. That would have been in my longer session, and if you look on YouTube, you'll find that this session is available. But essentially, the way class loading works now is slightly different because there are, in JDK 8 and earlier, there are 3 class loaders. The biggest change that I won't go into too much detail about is that the boot class path class loader has gone away. There are still 3 class loaders that enable you to load different classes. The big difference is that you've got one class loader that loads certain parts of the system with full permissions, and then you've got another class loader that will load modules with only restricted permissions to make life better from a security perspective. But yeah, it's a much longer discussion, I'm afraid. Last one.
The first one is, can I have different levels of authorization? And the second is, can I have just one module deployed with a different version as kind of?
So different authorization. No. There's nothing in the specification that deals with authorization of modules. So that's something which is outside the scope of Jigsaw. So that's a no. And the second question was around...
Can I have a new version of a module and just deploy that alone?
Yes, but bear in mind that the versioning number doesn't have any effect. So what you would you could certainly do that, but you'd have to do... No, because you can put the module on the module path. So that's the idea. You don't have to put it all in one monolithic jar or ir or war. You can put it in a module, and then you can just replace the module in your system. So that will make life a little bit easier. Okay. Unfortunately, I have run out of time. So thank you very much.